Okay, so what if I told you that the universe isn't, well, a thing, not a container full of stuff, but something more like a dance? Today, we're going to dive into this pretty radical new theory that flips cosmology on its head. It says the universe isn't a story about matter and energy, but a breathtaking geometric waltz. And this right here, this is our starting point. This single elegant sentence kind of holds the entire theory in miniature. I mean, it's pretty mysterious, right? General relativity is the score, 3/2 is the time signature. What does that even mean? What score? What time signature? Well, stick with me because that's exactly what we're going to unpack. Okay, so every dance needs dancers, right? And in this cosmic waltz, we've got two fundamental partners. And it's their interaction, their relationship that defines, well, literally everything. So let's meet them. So on one side, you've got space. Now just think of this as the grand, sweeping ballroom floor, you know? It's continuous, it's smooth, it can curve and bend. This is the kind of geometry you know from Einstein. But then you have its partner, the surface. And this isn't the floor. It's more like, imagine a sequence of defined footsteps lighting up, one by one. It's discrete. It samples reality in these distinct steps. It doesn't flow. So you get this really fundamental tension, right? One partner is all fluid glide, and the other is this precise staccato rhythm. All right, let's get a little more specific and put some formal labels on these partners. For space, the theory is using the geometry of what's called a three-sphere. The easiest way to think about it is like the surface of a ball, but just add an extra dimension. Its curvature is something we can actually measure. Now the surface, that's a bit more exotic. It's this complex, discrete structure, and it's where the observer, you know, the one doing the measuring, is actually located. Look, don't get too hung up on the technical names here. The main thing to get was that these two are fundamentally different kinds of reality. Okay, so if these two partners are so wildly different, one's all continuous and flowing, the other's all discrete steps, how in the world do they dance together at all? What's the thing that connects them? And this right here brings us to the most crucial part of the whole theory, the time signature of the waltz. I mean, that really is the central question, isn't it? You've got a smooth, flowing dancer and a stepper. How do you even choreograph that? What's the rule? What's the step that lets them interact? Well, the answer isn't some kind of force. It's just a number. This is it. 3/2. That's the magic number. It's the time signature from that quote we started with. And this simple ratio, that's the fundamental step of the dance. In fact, in this theory, this ratio is gravity. So the big question is, where does it come from? Okay, let's break it down. The 3, that's the easy part. It represents our partner, space. It's simply the 3 spatial dimensions we all know and live in. It's the 3-ness of our reality. The 2, you can probably guess, comes from the other partner, the surface. It's fundamentally a 2-dimensional structure. And what's really fascinating is that this 2 also connects directly to how general relativity itself describes the energy of empty space, what we call the cosmological constant. So you've got these 2 numbers. Now let's see how they build the bridge between our dancers. So get this. Gravity is not a force pulling things together. It's a conversion factor. It's basically the geometric price you pay to translate information from that 2D discrete surface into the 3D continuous space. It's the bridge, the interface. It's that elegant waltz step that allows these 2 totally different partners to talk to each other. All right, now for the really big payoff. Because this elegant idea of a geometric dance, it doesn't just sound cool. It claims to solve the single biggest mystery in all of physics, the whole problem of dark matter and dark energy. So here's the mystery in a nutshell. Everything we can see and touch, all the stars, all the galaxies, you, me, everything, it makes up only about 5% of the universe. The other 95%? It's a complete unknown. We've just given it these placeholder names, dark matter and dark energy, basically because, well, we have no idea what it is. And we have spent decades and billions of dollars searching for the particles that make this stuff up. And you know what we found? Absolutely nothing. And this theory gives a brilliantly simple reason why. According to this model, we haven't found them because they aren't there to be found. Dark matter isn't some exotic particle. It is the gravitational effect of the continuous 3D space itself. And dark energy isn't some weird fluid pushing things apart. It is the fundamental energy of that 2D discrete surface. Think about that. The missing 95% isn't stuff at all. It's the 2 dancers themselves.
Okay, but what about the evidence? Our best evidence for dark matter particles comes from things like the bullet cluster. The standard view is pretty straightforward. You have two galaxy clusters that collide. The normal matter, the gas, smashes into itself and slows way down. But huge clouds of invisible dark matter particles supposedly just pass right through each other, like ghosts, and keep on going.
But the Waltz view, wow, it offers a stunningly simple alternative. It says the collision just made the two dance partners visible for a moment. The continuous geometry of space, that's what causes the gravitational lensing we see, it has no physical stuff to it, so it just passes right through itself. Meanwhile, the discrete surface modes, which is what we see as gas and normal matter, they absolutely can interact and collide. See? No extra particles needed. The separation we see is the dance itself, finally revealed.
And this is way more than just a clever explanation for one puzzle. This whole geometric framework seems to elegantly resolve some of the other really deep, nagging problems in fundamental physics. Like, for instance, why has it been so impossible to create a quantum theory of gravity? This model basically says we've been asking the wrong question the whole time. You can't quantize gravity because gravity isn't a fundamental force to begin with. It's an interface between a continuous reality and a discrete one. Trying to quantize it is like trying to force a painter's smooth brushstroke to be made of individual Lego bricks. It just doesn't work. The two systems are fundamentally incompatible, and that incompatibility, that's the whole point. And get this, it even redefines what mass is. So picture our two realities again, space and surface. In this theory, some particles, like photons, they only ever travel within the continuous space. They never touch the discrete surface. And because they don't cross over, they're massless. But other particles, they do cross that boundary. And that interaction with the surface, well, that's what we perceive as mass. So mass isn't something a particle has, it's a description of how it dances.
And this is where it all just comes together so beautifully, in what the theory calls the division of labor. I mean, just look at the elegance of this. Every single piece of the geometry has a specific job. The 2D surface, that sets the universe's background energy. Another geometric structure, that determines exactly what kind of particles can even exist. The position of the observer, that sets the fundamental constants of nature. And the 3D space provides the curvature we feel as gravity. It's a complete, self-contained architecture for reality, where everything we thought was arbitrary just emerges naturally from the geometry itself.
And that really brings us to this final, pretty profound thought. For so long, we've been searching for 95% of the universe as if we lost it somewhere. But maybe it isn't lost at all. Maybe that 95%, the geometry of space and the energy of the surface, maybe it's the very structure, the cosmic instrument that allows the 5% of light and matter to even exist and be seen in the first place. So what if the real mystery isn't what's hiding in the dark, but what the darkness makes possible?